Hi everyone! In this project, I built a machine learning model using Excel to predict the electrical energy output will be denoted PE of a combined cycle power plant based on environmental features such as temperature, denoted T, exhaust vacuum, denoted V, um, ambient pressure, denoted AP, and then relative humidity RH. So the goal for today is to model PE, electrical energy output, using all of these variables. So as I just showed you guys, I already have all the variables sorted into columns. And since PE is a continuous variable, this is a regression problem. So I started by splitting the data into an 80% training set and then directly a 20% test set. I did this manually in Excel by copying around 7,600 rows into a new sheet for training, which I then named the training set, as you can see right here. So in the training set, I have all the columns with all the variables already. And to build the model, I directly used Excel's regression tool under the data analysis tab. And for the first models, I used all the variables, all the 4 environmental features, which are temperature, T, and then V, AP, and RH. And then for the Y, I used PE. So then in the data analysis regression tool, when you go to Y range, there's PE column, and then the X range will have T, V, AP, RH. So then after using the regression analysis, Excel gave me all the coefficients, intercepts, and R squared. So then I used them in the regression equation to predict PE for each row in the test set in a new sheet, which I named testing set. As you can see, I just opened it here. And then we're going to take a look at the formula for the first row. So as you can see, the first number here, the 449.2 will be our y-intercept. And then we have A2, which is the AT value times its coefficient that we found in our training set. And then we're going to do that for every variable, add them up together, and there we're going to have our predicted PE equation. Then I started calculating the prediction errors. So as you can see here, we have our absolute error, mean absolute error, and then our root mean squared error. So then for model 1, the mean absolute error was of 13.78 and the root mean squared error was of 14.45, which was too high. So then I wanted to use a second model by using only the 2 most important and impactful features, which I found out to be temperature and vacuum, using our coefficients. So when I did the new model, this time only using the 2 variables, the 2 most impactful variables, this time the mean absolute error dropped significantly to 3.9. And then if we look at our root mean squared value, which drops significantly too, to 4.9, which is a huge improvement. Then I created another model using only 80, AT, and V variable because they're most relevant. In order to see if there's a meaningful difference, to see a potential increase in accuracy and hopefully a decrease in root mean squared. And yes, as you can see that there's a big decrease in the 2. So lastly, I compared the 2 models using the mean absolute error and the root mean squared error, which measures average error and penalized large errors respectively. The second model performs much better, so I selected it as my final model, since the PE values ranges from around 400 to 495 megawatts, and a 3.9 megawatt average error is very low, less than 5%. So to conclude, T and V were the most predictive variables because they directly affect turbine efficiency and steam pressure. By simplifying the model and focusing on the most relevant feature, I improved accuracy and reduced noise. In conclusion, I followed the full machine learning process in Excel because I identified the problem as a regression since PE was a continuous variable. I built and compared 2 models, the first one using all 5 variables and the second one using 2 variables. I evaluated them using the 2 errors. And then lastly, I selected the most accurate one, which was the second one, and interpreted the model. So thank you for watching.